Welcome on this primer on network analysis for business. In this presentation, we'll explain what networks are about, why is their analysis interesting, and why is it relevant for business. So first, we'll start with a definition of networks. It's actually very simple. You could say that a network is simply a data set of entities and their relationships. That's it. Basically a list of stuff and the connections between this stuff. That's a network. You will see in your readings that networks are sometimes called graph. You could say it's quasi-synonymous. So, in this presentation, I will adopt a visual approach in order to explain clearly the concepts. Let's keep in mind that networks, if they are just a list of stuff and a list of their relations, you could have a network represented in an Excel spreadsheet, right? Just a list of entities and a list of the relations between these entities. So it doesn't need to be visual or on a screen, but I use this visual approach because it facilitates understanding. So on this slide you see a network, an example. As I said, each blob on the screen is something. And so it can be anything, we'll see that later. And you see that these things are connected by links. So that's simply what a network is about. Networks, I mean, what are they made of? I said list of entities. What kind? Well, you could think of social networks. Here, this is a picture posted by somebody who made a picture of their Facebook friends. So each blob is a person, like somebody on Facebook, and you have a link between two persons if they are friends on Facebook. So social networks are quite familiar because we all use this or that social network. But this next slide shows you that we should not limit ourselves to thinking just about social networks. I like this example, which is by Lada Adamic and colleagues. She used to be a university professor at Michigan, and she's now a data scientist at Facebook, where she collected recipes on a large website where you find recipes. And with her colleagues, she basically found what were the ingredients most frequently mentioned in these recipes, and how these ingredients are mentioned in the recipes. So you have a connection between two ingredients if they are frequently used in the same recipe, if they are frequently mentioned in the same recipe. And you arrive at this kind of result. So, I mean, of course, not everybody is in the food and the recipe business, but it is just a very key point that virtually anything can be thought of as something that can be understood or visualized or explored as a network, including cooking recipes. Another example is text. Any kind of text can be represented as a network. So here you see, well, you say network, but there is no link. There is no connection. Well, sometimes you don't need to show in visual representations of networks. You don't need to really display the networks, the links on the screen what you can just show is, I mean, if two entities are connected, you just represent them as being neighbors on the screen, close one from each other. That's, I mean, you could trace a link between the two, but it's a bit redundant. As long as they are close one from each other on the screen, you understand they are somehow connected, and that's what was made here. Basically, a team of researchers collected many papers published in Nature and Science. These are two famous scientific journals. And they looked at the most frequent terms in these publications, and then they connected these terms in the case when they were used in the same papers. So when you collect hundreds and thousands of papers, you can arrive at this map. Again, the point of this slide is to insist that networks, it's not always between persons or objects. It can be networks of abstract things, and it's still very relevant. And finally, the networks we've seen so far just involved a couple of dozens of entities, but there is no limit. You can have networks that are actually huge. This one was created by somebody who basically recorded every Swedish speaker he could find on Twitter, and he created a map of these persons, or at least 50,000 of them, that you can see there. And again, we don't see clearly the links, but we don't need them. We just need to know that the blobs, or the entities that are sitting next to each other on the screen, are actually connected. So why would they be connected here? It's Twitter, so you might imagine that one is following the other, I suppose. And to leave the visual approach a bit on scale, where when you don't display networks on screen, when you just store them on computer and crunch them on computer, number crunch them on computer, well, one of the biggest network I've ever heard of is the one on Facebook, where researchers in 2011 made computations, or tried to describe the network of Facebook users. So it's 700 million of active Facebook users connected by 69 billion links. That's quite humongous to analyze. So networks can be huge. So far I've discussed blobs. I said blobs and entities. Let me share with you the proper way to describe networks, actually. Quite useful if you have to read anything on networks. Again, you call them networks or graphs. So the entities are called often nodes or vertex. When it's singular, you would call them vertices, plural. So these are the entities, the blobs you saw on screen. And the connections between them, well, you can call them connections, but you can also use the term tie or link or edge. Very often we are interested not just in the fact that two nodes are connected, but in the fact that the connection has a direction. So for example, I'm connected with somebody on Twitter, but there is actually a direction to this connection. I follow this person. So visually you would put an arrow to this connection, but without, even if you don't visualize the network, you can still take the direction of this connection into account. If the direction is of no special meaning, then you discuss of an undirected network. And two last things: when the connection between two entities has a strength or a value, you call that a weight, the weight of the connection, and then overall you have a weighted network. That is a network that includes connections that have a particular value. And last but not least, these nodes and their connections It's very important for, especially for business analytical reasons, to never forget that these attributes you can, these nodes, you can attach attributes to them. By which I mean that if you have person A which is connected to person B, you are not obliged to stop there. You can say that person B has a gender, an age, an address, and all of that can be represented visually on a network. So that I hope it gives you a clear picture of what networks are, but you might wonder what's the connection between the topic of networks and business. Well, let me list a few use cases where the two are actually connected. So if you followed the lecture on segmentation in this series in the course, you might recall that we discussed network analysis as one of the tools available to segment a market. So I just say the same here. If you have a network of customers where two customers are connected, if in your CRM you found that they were similar in some sense, same demographics, same past transactions, same preferences, same or similar response to your ad campaigns, then you can end up with the network that you see on the left, which frankly doesn't tell much. But when you look at the same graphic, the same network on the right, that's exactly the same. We just applied a community detection algorithm. Again, that's simply an algorithm that finds the nodes in the network that are strongly connected one to each other and poorly connected with the rest of the network. Well, you see on the right that we learn a lot. We see that our customers are actually organized in some way, with groups of customers being more connected, more similar one to another. Well, that's very useful if you want to actually segment your network. So segmentation is really something that is facilitated by a network approach. In terms of vocabulary, I should highlight here that you will this segmentation on networks will be called community detection approaches. So you don't say segments but communities. You might also hear about clustering. Clustering is or partitioning. These are other synonymous ways to discuss how a network can be divided into segments. Clustering, partitioning, community detection. Networks are also interesting if you are looking for key players, for special individuals or special objects or special entities in your network. You have 1 million entities connected one to another. Which one stand out? Well, organizing these entities as a network, as you see on the left, and then applying some simple algorithms, and you see the result on the right, gives you some potential candidates that you could be interested in. For example, the bigger node on the biggest node on the that you see on the right, the kind of reddish one, is bigger because we simply computed the number of connections per node, and then we said please make bigger, please draw the nodes in a bigger size if they have a lot of connections. And the red one apparently is the one that has the most connections. So that's interesting. You could also apply things a bit different, where it's not about having the most connections that is important, but it's actually being the most at the center of the network. And you know, having the most connections does not always put you at the center. I don't want to enter into details, but you have cases where you can be at the center without having the most connections. Well, you could find in a network approach this kind of important persons. or as I highlighted here, gatekeepers, individuals or concepts or entities that have a special place in the network because they are basically bridging two different communities. The blue node that I highlighted could be interesting because if you want to move from the network to the blue community, you are almost obliged to go through this person to reach on the other side. So this person is not the most central overall, but still this person can be quite important to reach if you want to reach the community behind it, the community of blue nodes. So networks allow you to find key players. That's that's quite precious. Next, networks allow you to understand how information spread. Here I take a screenshot from one of the tweets I posted. When was it? Maybe in summer 2014. And using the free service available on where does my tweet go, wdmtg.com, you can actually have a visual representation as a network of how did your tweet spread. People retweeting it, and then people retweeting the retweet, etc. Actually, on screen, on the website, you would see an animated version of that. But here in the screenshot, you understand already the principle. You see that from the first tweet at the center, the information spread to the first person who retweeted, and then retweeted again and again. So networks provide a very convenient and intuitive way to think of how information spreads, and to understand how a campaign spreads, how word of mouth actually works. Networks help you do this analysis. And finally, related to the previous slide, but here really full scale, networks allow you to see how networks evolve in time. So it's not just about how we saw in the previous slide how information spreads on the network. It's about how the network itself evolves, with nodes appearing and disappearing, with ties being created or being deleted. And you have software such as Gephi, which is the one being used in this publication. You have software that allow you to study and represent the evolution of dynamic networks through years. This one represents an evolution in 5 years, and through very detailed levels. Here we see all transactions between banks active on the Dutch market, and we see all of these transactions. So you can have a very macroscopic view of a data set, all while being able to drill down at the most detailed level, because you can pause at a particular day and zoom in on a particular bank, and then look at the particular value of a transaction. So you see, you see both sides of the data set, which is again something which is very hard to do, and you can't see many other analytical approach that gives you both the macroscopic and the microscopic views on a data set. So that's it for networks. I finish with suggesting a couple of titles a couple of books that would give you a kickstart in network analysis. I personally like very much the second one from the left, Analyzing the Social Web. In a very simple way, it covers many of the essential topics you would need to use network analysis in a business environment. Thank you.